Okay, so for today we'll concentrate on question 2, which just say I can say the third Newton's law. So on the third Newton's law, these are the questions that you will be facing. What are the questions? They're saying the question says a 20 kg metal block is placed on a horizontal surface. The block just began to slide when the horizontal force of 100 newtons is applied to it. The first question says calculate the coefficients of the static friction. So how do we find this type of the question? So the first thing that you need to do here in this situation, you have to say, just draw a free diagram like this, right? Remember that we're applying the force in the horizontal direction like that. So if you're applying the force in the horizontal direction, which is going like that, meaning this is the applied force. Then on top here, that's what? Normal force. Then the down part, which is here, that's what we call gravitation. Then this side is what we call what? The friction force, like that. So from there now, here they have given you already the applied force, which is what? 100 newtons. How about the mass of this block? The mass of this block, which is 20 kgs. So they're saying that to calculate the coefficient of the static what? Friction. So how are you going to calculate the coefficient of the static friction? So the first thing that you need to do here, let's make the equations, right, that are acting on this block. So we have the sum or summation of the forces in the x is equal to the force applied minus the friction force that is in the x-axis. How about in the y-axis? We have the force in the summation of the forces in the y-axis. We have the force in the normal direction and minus the what? The force in the gravitation. So if you look at here we have the force that are going to the positive way and the forces that are going to the negative side. These are the forces that are going to the positive, and these are the forces that are going to what? Negative. That's why all of them have put them to be negatives. So from there now, let's go and answer our question. So our first question, it says calculate the coefficient of the static friction. So how can you calculate that one? Where will be the coefficient of the static friction? So if you check out, you will find that the coefficient of the static friction, it is found in x-axis. So meaning that you will get the summation of what? Of x-axis, which is FP minus F friction. So this part here, it is 0 here, right? How about the put force? Remember that the put force, it's 100. So what will happen to the friction force? The friction force, remember what's the formula for friction force? It's mu times the what? Normal force, like that. So mu here to be 100, here to be what? 0, like that. Then this is 100. Now, what is the normal force in this situation? The normal force in this situation will be what? Fn is equal to what? To mg. This Fn, which is here, which is equal to what? Mg, which is there. So meaning that what's the force? What's the mass of the block? Is 20 times 9.81. After you have multiplied with 20 times 9.81, you will find the answer as 196.2, like that. So this is 0 is equal to 100 minus, that's mu, so meaning it's supposed to be 196.2, like that. When this one goes the other side, means to be mu there, 196.2 is equal to what? 200. Divide by 196.2. Divide by 196.2. Such that in this one, when you divide to be 1 there, then but when you divide 100 divide by 196, you will get something like 0.51. So that's the coefficient of the what? Coefficient of the static what? Friction force. So it means that we have answered question 1. Now let's also go on question what? On question 2. So question 2, they're saying that if the coefficient of the kinetic friction force, now you have been given the coefficient of the friction force, which is this, then find the minimum force to maintain its what? Motion. So how are you going to solve on this type of the question. So in this type of the question, remember that the put force in the x-axis, the put force which is here, right, which is here, the put force which is here, it is equal to the friction force, which is this one. Then which is the put force is equal to what? The friction force. Then the put force, remember what is the friction force? The friction force is mu, then what? Fn. So if the put force is mu times what? Fn, what times the normal force, meaning that I want you to look at this, meaning that what is the normal force? The normal force will be equal to mg here, right? What's the mass? It's 20 here. And 9 times 8, 1. You find that your answer is 196, right? 196, right? So that's your normal force, which is here. Now let's find the put force. So meaning that the put force here, they've already given you the mu, which is for the 0.4 times the 196. So what would be the answer? So it will be 0.4 times 196. So you will find your answer to be 8.48 newtons. This is how you calculate that. So let's go on the question 2. So question 2, they're saying the block of the mass is placed on the rough surface. The coefficient of the static friction force between two surfaces is 0.2. Then what is the minimum horizontal force required to move the block? So remember, it's just the same with the one that we're doing, which is the applied force is equal to what? Friction force, like that. Then the friction force is mu times the normal force. Now that's a friction force. How about the normal force? The normal force is mg according to this situation, such that we end up to have mu here. What's the normal force? It's mg, like that. Then what will happen? It will be the applied force. What's the friction force? It's mu times mg, so it will be mu times mg. Then what's the mu? The mu is 0.2 times 3 times 9.81. Then what's the answer altogether? You have to find 5.6 newtons, like this. So this is how you calculate that answer. Now let's go on the another one. The another one, it says suppose you move the crate of 500 kg by pulling upward on the rope at an angle of 30 degrees Celsius above the horizontal. So in this situation, the first thing that you need to do is to draw the free diagram, because the free diagram is the one that will help you to locate all the forces that are being applied on the crate in this situation. So here we're applying the force at an angle like that. If you're applying the force at an angle like this, this meaning that the forces are divided in the y again in the what? In the x-axis. So if this is the applied force, which is here, meaning that here it will be what? Applied force sine what? Theta. Here to be what? FP here cos what? Cos theta, like that. Then how about on top? Here it will be on top here, which is there, right? This is the normal force, like that. Then what will be the down part? Let's see, mg. Then this side is what we call what? Friction force, right? So this is your free diagram. After drawing the free diagram, then they're saying suppose you move the crate of 500 kgs by pulling upward on the rope at an angle of 30. So meaning the angle is 30 above the horizontal. So the first question says if a block is put with a force of 250, calculate the normal force. So remember that on this question, the normal force, we can only calculate the normal force in the y-axis. So meaning that you have to get the forces that are in the what? Y-axis. So let's take the summation of the forces in the y-axis. We have the normal force that is going to the upside, which is the positive, minus the mg, which is going down here, then plus this one, which is going up there. So it will be plus f p sine what? Theta, like that. Then what are they asking? They're asking us to calculate the normal force, meaning this part will be 0 to the fn minus mg plus fp sine theta like that. So here we're looking for the normal force, so meaning that we will make Fn to the subject of the formula such that it will be Fn here is equal to mg minus Fp sine what? Theta like that. So what is the m? What's the mass? So the mass in this situation is 500 times 9.81 minus. What's the force? The force applied in this situation, it's here, which is 250. So to be 250 here, sine that. So what will happen is that right, 500 times 9.8, you get 44905 minus everything there, you will get what? 1.5. Then meaning that your normal force will be 4780 newtons. So this is how you calculate what? The normal force. So how about this, the other question? The other question says, which is this one, they say the friction force on the block, assuming that uk is that. So now the friction force, right? Remember how do you calculate the friction force? It's mu here, now it's k times what? The normal force. So meaning that what is the uk? That is 0.4. Then the normal force 47.8. So that's the normal force. So meaning that when you multiply there 0.4 times 47.80, when you multiply you will get like 1912. That's the friction force that is resisting this object. So from there now let's go on the other one. We're saying the acceleration of the what? Of the block. The acceleration of the block. So how do we find the acceleration of the block? So in this situation, what you need to do is that you have to find the summation of all the forces in the x-axis. So in the x-axis in this situation, we are having what? Fp cos theta minus the friction force. So this side where there is Fx, that side we replace with the ma, because force is equal to mass times the acceleration. That's why I've replaced it with what? Ma like that. So the ma is equal to p here cos what? Theta minus friction force. So what's the ma? Mass a, that's a mass, right? M. Then a is the acceleration. So here the applied force we had 250 cos 8 minus what's the friction force? That was 19 what? 12 like that. So to be 500 a is equal to, then you get a negative, which is negative 97.979. It's not 1695. Like you see 95.5 like that. Then let's divide this by what? By 500. Meaning your a will be, what? Negative 3.40 meters per what? Per second squared. Negative 3.40 meters per second what? Squared. So that is your acceleration. Now they are saying how hard you must put to keep the crate what? Moving with a constant what? Velocity. So in this situation, how are you going to find this type of equation? So here we still get the equation that is in the x-axis, the same equation. Now where there's f, we just replace with a 0 so that we can find the put force, how much force that we can pull to keep this what? Moving. So this is 0 like that. That is 500 cos 500 cos theta. Oh no, you're supposed to put 500 in, because we're looking for that force which is here. Put force here, right? Minus what's the friction force? The friction force is 1912 like that. Then this part will go this side, meaning that it will be Fp cos theta then equal to 1912 1912 over cos 30 over cos 30 over cos 30, meaning that FP is equal to what? FP is equal to what? You'll find an answer which is 2.208 meters, just like that. So that's your what? The FP, the put force in that situation. So that's how you answer this question. Let's go into another question. So if you have this type of the question, I think a man is holding a box 100 kgs up at 5 incline by a rope attached to the rope of the box as the rope in the figure below. If the rope makes an angle 20 to the incline and the coefficients of the friction between the box and the incline is 0.65, calculate the force applied by the man to keep the box moving at a constant what? Speed. So in this situation, what do you do? The first thing is to draw the free what? The free diagram. As I said, you have to draw the what? The free diagram. This it helps given the identification of the forces. So in that situation, we have this part, right? We're applying the force which is this side, right? This is the angle which is 20, and this is the angle which is what? 35. It's the angle that is 35. Then we have the normal force. Down part, we have the what? mg cos theta. How about this side? We have the mg sin what? Sin theta. Then we have also the friction force this side. So here what we're looking for the put force, right? That's asking us to calculate how much put force was put in order to move that object, to move that box. So what are you supposed to do in this situation? In this situation, let's come up with all the equation or the summation of the forces in the what? In the x. Let's do that one. So remember we have the force that is being put this side. If this one is at an angle, so this one it is sin theta, then this one it is cos theta. So meaning that it will be F cos theta plus or minus, not plus, to be minus, right? Minus friction force minus mg sin what? Sin theta, like that. Those are the forces in the x. Now let's go on the forces in the y. So what are the forces that are in the y? We have the normal force minus mg cos theta plus f sin theta, like that. So those are the forces that you are having, right? The summation of the forces that you are having in the x axis, again in the what? In the y axis. So now what are we looking for? We're looking for the force that was applied to that object so that it can what? It can move. So what do you do in this situation? In this situation, we shall use the x-axis force, because in the x-axis force is the one that is, it has the what? The normal force. So let's use that one, meaning this part will be 0 there. Let's say Fn minus mg cos theta plus f sin what? Theta, like that. So it will be Fn here is equal to, when everything goes the other side, that is mg positive cos what? Theta, like that. Then minus f sin what? Theta, like that. Now we have the normal force. Excuse me. We have the normal force which is mg cos theta minus f sin theta, like that. That's the normal force. So that's your first equation. You go back again in the y, in the x-axis equation, which is this equation. You get this equation again. So it will be 0 there. It will be f cos theta minus friction force minus gravitation force in the x-axis, like that, right? So where is the weakest point? The weakest point is where there's a friction there. So we say 0 is equal to f cos theta minus the friction force, which is the mu times the normal force minus mg sin theta. So meaning that wherever there is the normal force, now we replace with it this equation there. So let's do that. So meaning that it will be 0 is equal to F cos theta minus mu there, which is mg here, cos theta minus F sin what? Theta minus mg sin theta, like that. So that's what you have found there. This is 0 there, it is F cos theta there. When you multiply everything, it will be negative mg cos theta positive mu here F sin what? Theta minus mg sin theta, like that. So from there now, let's put together the F's, right, so that we can find the force. So how are we going to do that one? Meaning that we have all of these, this one and this one, they'll jump to the equal sign, right? So it means that we have F cos theta here, like that, plus mu F sin theta is equal to mu mg cos theta plus mg sin what? Theta, like that. So here, what's common? We're looking for the F. So meaning that if you're looking for the F, what are you supposed to do in this situation? Let's factor out the F that we're looking for. So we factor out the F, we remain with cos theta here plus mu here, then sin what? Sin theta, like that, is equal to, if you have still this part, which is mg cos theta plus mg sin what? Theta, like that. So from there now we make F to the side of the formula by saying cos theta plus mu here, then you divide there, right, which is cos theta here plus mu, and then sin theta, like that. So now we have made F to the side of the formula because this part divided with this part. So we have made F to be the subject of the formula. So since we have done that, let's continue so that we can find the values of what? Of F. So that we can find the value of F. So remember that you have F is equal to mu mg cos theta plus mg sin theta over cos theta plus mu sin theta. Now let's substitute all these, right? What's the mass? So let's start with the mu. Since as we're starting with the mu, so the mu is 0.65 times the mass, which is 100, then 9.81, then cos what? Cos the angle, which is 35 there, like that, right? Plus you're adding, which one are you adding? You're adding that one, so meaning it to be plus what? To be plus which is mg, so to be plus 100, that's 100, there's 100 times 9.81, like that, sin 35 over what? We have cos 70 plus cos 20, no, sorry, so let's 70 cos 20 plus what? Mu, right? Plus mu, which is 0. Which is 0. What? Mu, we had 0. And mu we had 0.65, then sin 20, then everything after you find everything, you need to calculate the answer to be 933 7 newtons. So this is what the answer. So this is how you calculate in this situation. So meaning that here the force that was supposed to be needed for this to be moved. It's 937 newtons, like that. So that's how we answer that one. So how do we answer this one? So we answer this one. The first thing is do the same thing. The free diagram is simple, but this is the normal force, and this is the what? Mg cos theta. Then this side, they are applying the force, and this it's at an angle, right? If it's at an angle, meaning that we have F sine theta here, then here we have F cos what? Theta, like that. So in this situation, we have the mg which is going down there, mg sine theta, and the friction force. So they're saying calculate the normal force. Remember that if they ask you to get the normal force, meaning that you're getting the forces in the what? In the y-axis. So get the summation of the forces in the y. After getting, you will have something like a normal force here up minus mg cos theta plus f sine theta, like that, right? So from there now, let's make fn to be the subject formula. So it means that fn here, everything now, it will go the other side. This one will go the other side, it will be positive one, but this one go the other side, it will be what? Negative. So what is the mass in this situation? The mass, we had the 10 kgs, 9.81. Then the angle is 30 minus, what's the force applied in this situation? That is 20 there. Sine what? Sine, supposed to be sine what? Yes, sine 10. Sine 10. Then what is the answer there in that situation? So in that situation, the answer will be 81.5 newtons. That's the answer. Then the next question we say calculate the friction force. So remember that the friction force, we say what? It's mu, then times what? The normal force. So what's the mu here in this situation? The mu here is 0.2. What's the normal force? That's 81.5. Then what's the answer? The answer will be 16.3. 16.3 what? Newtons. Then the next part is say calculate the acceleration of the what? Of the block. So how do we calculate the acceleration of the block? Meaning that we have to use the values in the y-axis. Okay, so it will be ma here is equal to x, the calculate the acceleration, right? So remember that we have to get the values in the what? In the x-axis. So meaning that we have the forces that are moving in the x-axis, we have what? F cos theta minus mg sine theta minus friction force, like that. So what's m? That's 10. The acceleration is equal to applied force 20 cos what? Cos 10 minus what's m? That's 10 times 9.81 sine what? Mg, that is sine what? Sine 30 minus the friction force, which is 16.3. Then you will find an answer, which is 10a here. You find an answer which is having a negative. And we shall find the answer that is having a negative. So okay, let's bunch that with 20 cos 10. 20 cos what? Oh, there's 20 cos 10 minus, that is 98 and 1 sine minus 16.2 minus 16.2 something 0.3, then you will find something like negative 13.05, then you divide by 10. So that's how we find the acceleration. So meaning that it will be negative 0.130. Right, that's right. So that's how what you do that one. Now let's go to the last question. So on this last question, it says a 5 kg object placed on the frictionless horizontal table is connected to a string that passes a pulley and then is fastened to a hanging 9.00 object as in the figure below. Draw the free diagram of the both objects. Right? So we here they're saying that there's no friction. So we have the force that is going like this. So meaning this is what? Friction. This is the force that is going like that, but doesn't have any friction. Then we have the other part, which is this part. It's going up, it's going down here, right? Meaning that this side is, that's where the tension is, right? So if we have this force which is here, right? Let's identify the forces that are here. This is the normal, right? And this is the gravitation. That's the same way. On top that's the tension, and the down part is what? Gravitation. So in this type of the equation, the things that we need to know here is that the things here you need to know is this. They're saying find the acceleration of the two objects and the tension in the string. So here what you need to do here is say MA for the first one, right? MA for the first one. How many forces? Only one force that is going to the positive direction. Remember, when it's going like this, the point where it is going, that's where it will be positive. So meaning that here it is positive t. So here it is what? Positive t, like that. Right? Then the other part that is MA here is equal to, here that's the point where it is positive, right? It's going where it is positive, but it is be subtracting where it's what? Negative. So meaning that the down part will be what? The down part here will be mg, which is positive, minus t, like that. So meaning this is your first equation and this is your what? The second equation. So from there, what do you do? Remember that it's in this is minus 1 and this is minus 2. So you have the minus 1 and minus, we have the equation 1 and equation 2. So it will be m2 there, m2g minus t. So let's calculate here now, right? What's on the minus 1? The minus 1 is 5 is equal to a is equal to what? To t. Then the other one is what? It's 9a is equal to 9 times 9.81, that minus t. So what are you going to have? You will have something like 9a minus is equal to 5 times 9.81, and here to what? 49.05 minus t, like that. So in this situation, here are the rules. Now we have that, meaning that we can solve those in what? Simultaneous equation now, right? So we have 5a is equal to t, like that, and the other one of 9a here is equal to 4.05 minus t. So here we can just go direct, which is say 5 plus this, that is 14a, like that. Then this one and this one they'll cancel because this is positive and this is negative. So it will be 49, that will remain like that, divided by 14, divided by 14. Then your a will be is equal to, that is answer divided by 14, that is your answer will be, so to be 49 divided by 0.5 divided by 14. 49 9 times 9.8. Oh, here supposed, sorry, here supposed after you have multiplied this, supposed to be 80 8 here, 8 8 here. After multiplying that, this is 88 88 like that. So meaning that A is equal to 88 divided by 14, and your answer, the first answer, 6.30 like that. 6 is meters per minute, it's seconds squared like that. That's your A. Then let's calculate the tension now. Then the tension, how do you calculate the tension? You get any of these equations, right? The one that you found and the one that you haven't found, like that. So here to be 5A is equal to T, right? So meaning that we can find the value of T by substituting where there is what? A. So to be 5 times 6.0, then your answer will be at 1.5 meters. So this is how you calculate your thing. So for today, let's end from here. We'll continue next time.